Good morning, everyone. In the last session, we have discussed some topics which are related to thermodynamics and our very first chapter, fundamentals of thermodynamics and perfect gas laws. Right. So, in the last session, we have discussed some topics like what is thermal equilibrium, what is zeroth law of thermodynamics, what is first law of thermodynamics. So these things we have discussed in our last session. Now just we will recap the things what we have discussed in the last session and shortly. Right. So thermal equilibrium. What is thermal equilibrium? Thermal is nothing but heat, which is related to hotness of a body. Equilibrium means all the properties are in the same state. Right. So thermal equilibrium is nothing but a system or a body. A system or a body is said to be in thermal equilibrium. A system or a body is said to be in thermal equilibrium if the properties of the system will not vary by themselves. If the properties of the system will not vary by themselves is known as thermal equilibrium. So with the example we can understand in a good way. That is, consider two bodies, one body which is at a higher temperature and the other body which is at lower temperature. The higher temperature is nothing but consider it as a hot body, and the lower temperature is nothing but consider it as cold body. So generally we know that fundamentally heat will always transfer from higher temperature to lower temperature. It will always transfer from higher temperature to lower temperature, right? So the heat flow from hot body to cold body due to temperature differential. The difference in temperature between the two bodies, the difference in temperature between the two bodies decreases with time, and finally they reach to the same temperature, and further heat flow will not take place, right? So two bodies which are at two different temperature, one is called as hot body and the other is called as cold body. So heat will flow from higher body to lower body, due to the temperature difference. After a certain time, the heat transfer, after a certain time the temperature between the two bodies will be same. That means there will be no further flow of heat in between the two bodies, because because no transaction of energy from one body to another body and no further change of any property occurs. So generally this condition is referred as thermal equilibrium. So no transaction of energy from one body to another body means as the two bodies reaches the same temperature, so there will be no transaction of energy and no further change of any property occurs. So property means temperature. There will be no temperature. Alright, so there will be no change in the temperature. So then the body is said to be in thermally equilibrium. Then the body is said to be in thermally equilibrium. Right? Now, next one is zeroth law of thermodynamics. What zeroth law of thermodynamics? Zeroth law of thermodynamics is concerned with thermal equilibrium. It is mainly concerned with the thermal equilibrium. So it is the basis for all thermometry. It is the basis for all thermometry. Nothing but the measurement of temperature. Right? So what exactly the zeroth law of thermodynamics statement? It states that when two bodies are in thermal equilibrium with a third body, when two bodies are in thermal equilibrium with a third body, so when two bodies are in thermal equilibrium with a third body, they are in thermal equilibrium with each other. They are also in thermal equilibrium with each other and hence are at the same temperature. So two bodies are in thermal equilibrium with a third body means, let us say the body A and body B. These two bodies are in thermal equilibrium with a third body which is known as C. Then as per the statement, the bodies A and B are also in thermal equilibrium with each other. So this is the statement of zeroth law of thermodynamics. So if the bodies A and B are in thermal equilibrium with the body C, then A and B must be in thermal equilibrium with each other. So zeroth law implies that the bodies A, B and C, that the bodies A, B and C are also at the same temperature. These are also at the same temperature. So this is the zeroth law of thermodynamics. So what are the limitations of zeroth law of thermodynamics? The limitations of zeroth law is that it cannot be derived from other laws. It cannot be derived from other laws and cannot be applicable for other kinds of equilibrium. Other kinds of equilibrium means different types of equilibriums are there, known as mechanical equilibrium, chemical equilibrium, thermal equilibrium. So only it is applicable for thermal equilibrium and it cannot be applicable for other equilibriums. Right? This is This is regarding zeroth law of thermodynamics, and next one is first law of thermodynamics. So first law of thermodynamics is also known as Joule's law. It is a special case of law of conservation of energy. It is a special case of law of conservation of energy. So what is the statement of first law of thermodynamics? So first law of thermodynamics states that the heat and work are mutually convertible. It states that the heat and work are mutually convertible, and the creation of energy from nothing cannot be achieved. The creation of energy from nothing cannot be achieved. Right. So this is a statement of first law of thermodynamics. That means heat and work are mutually convertible. Heat can be converted into work, and work can be converted into heat. So these are mutually convertible. So as per the statement, the equation can be written as in a cyclic integral. In a cyclic integral, dq is equal to cyclic integral of dw. So dq is equal to dw, right? So whereas dq is equal to amount of heat transfer or net heat transfer, dw is equal to amount of work transfer or net work transfer. As the both are related to energies, heat and work both are energies, the unit for heat transfer and work transfer are same. Either we can write as joules or kilojoules. Right. So this is about first law of thermodynamics. Now this first law of thermodynamics is applicable for two systems. First law of thermodynamics is applicable for two systems. One is open system and the other one is closed system. First law of thermodynamics applied to closed system and the other one is open system. So when it is applied to the closed system, it is known as non-flow process, as there is no flow. Right. So in a closed system there will be no mass transfer, so the fixed mass will be there. So it is also called as non-flow process. Whereas in case of applied to a open system, there will be a flow takes place. It is known as flow process. Right. So non-flow process and flow process. Right. Now as per the statement of first law of thermodynamics, in a cyclic integral, in a thermodynamic cycle, the net heat transfer is equal to net work transfer. Right. So the net heat transfer is equal to net work transfer. For example, if a system follows a process which is not cyclic, then the final state differs from that of initial state. The final state is differ from that of initial state, and the difference between the energy input. So what is energy input here? Heat transfer. So heat is the energy input, and output. So in what form the output will come? The output will come in the work. So work transfer results in a change in the energy content. That energy is nothing but internal energy. Right. As per the first law of thermodynamics, it states that in a cyclic integral, the net heat transfer is equal to net work transfer. Suppose if a system does not follow a cyclic process, which is not a cyclic, the final state will be obviously differ from that of initial state. So the difference between the energy input, nothing but input will be in terms of heat only, and the output will comes in terms of work. In a change results in a change in the energy content. This change is nothing but internal energy. Right. So we can written as energy input minus energy output is equal to change in internal energy, nothing but Q minus W is equal to U2 minus U1. So Q is equal to U2 minus U1 plus W. So the above equation is nothing but Q is equal to U2 minus U1 plus W is known as non-flow energy equation, and shortly we can written as NFEE equation. Right. So this is the first corollary of the first law of thermodynamics. Right. Now corollaries, we will see the corollaries of first law of thermodynamics. Right. Now, the objectives in this session, what we are going to discuss is we have to know the corollaries and the limitations of first law of thermodynamics. What are the corollaries and what are the limitations of first law of thermodynamics? And we are also going to study the second law of thermodynamics. Right. Now, first we will see the corollary of first law of thermodynamics. What is the first corollary is for isolated system. So we know that three types of systems are there: open system, closed system and isolated system. So for an isolated system, right, for an isolated system. What is isolated system? In which neither energy nor mass transfer will take place. Neither energy nor mass transfer will take place. So for an isolated system, Q and W are 0. So there will be no mass transfer and there will be no energy transfer, as Q and W, heat and work, are both are energy. So there is no energy transfer. These are equal to 0. And therefore U2 minus U1 is equal to 0. So how U2 minus U1 is equal to 0? As per the first law of thermodynamics applied to closed system, Q minus W is equal to U. As Q is equal to 0, W is equal to 0, so U2 minus U1 is equal to 0. So thus the internal energy of an isolated system is constant. So internal energy will be remains constant, nothing but U2 is equal to U1. This is our first corollary. Second corollary is the difference between heat supplied and work done during a non-flow process results in change in the property of the closed system, and that property is nothing but internal energy. So we have discussed for a cyclic integral in a thermodynamic cycle, heat and work are both heat mutually convertible. If a process occur, if a thermodynamic cycle, it does not follows a cyclic process, then the energy input will be different from that of energy output and results in a change in a property. That property is nothing but internal energy. The same here it is discussed, the difference between the heat supplied and work done during a non-flow process results in change in the property. That property is nothing but internal energy. And third one, a perpetual motion machine of first kind. A perpetual motion machine of first kind. In short, we can have written as PMM1 is impossible. So PMM1 is impossible. Why? How it is impossible? How it is impossible means a device that will deliver work continuously without input is called PMM1. So a device that will deliver work continuously without input. So obviously any kind of device, in order to work we have to give certain input. So without giving any input we cannot expect any kind of output. So if we are expecting any kind of if we are expecting some kind of output without giving any kind of input, that type of devices is known as PMM1. So device that will deliver work continuously without input is called PMM1. A PMM of first kind is impossible. So it is impossible thing, right? So without giving some form of input we cannot expect any output. So such a device is known as PMM1 and PMM1 is impossible, right? So these are the three corollaries of first law of thermodynamics. Now we will see the limitations, right? So as zeroth law of thermodynamics is totally deal with the temperatures, and whereas first law of so that from that we have studied the first law of thermodynamics, and first law of thermodynamics also consists of certain limitations. Now we will see what are those limitations. So first limitation is that it does not specify the direction of flow of heat and work. So first law of thermodynamics does not specify the direction of flow of heat and work. That means in which direction the heat is flowing or in which direction the work is flowing, it is not specifying. Simply the first law of thermodynamics is telling that heat and work are mutually convertible, but in which direction these are going, that is not specified, right? Second one, in practice it is possible to convert complete work into heat, obviously. So in practice generally we can able to convert complete work into heat, but only part of heat converted to work, not fully, means that the heat, energy and work are not fully mutually convertible. That means we can able to convert work into heat, but we cannot able to convert the full amount of heat into work. We cannot able to convert full amount of heat into work. So heat energy and work energy are not fully mutually convertible, right? And next one, it does not help us to predict whether the system will or will not undergo a change. It simply states that during a process, heat and work are mutually convertible if system undergoes change of state. That means it is telling that It is just only predicting whether the system will or will not undergo a change. Maybe it will go or it will not go. It simply states that during a process, heat and work are mutually convertible, right? So the system may undergo a change or does not undergo a change, but simply it is saying that heat and work are mutually convertible. So these are the limitations. So these are the limitations of first law of thermodynamics, right? Now first law of thermodynamics applied to open system. Open system is nothing but flow process. Open system is nothing but flow process, right? So for a flow process, two types are there. It is subdivided into two types. They are mm, steady flow process and unsteady flow process. They are steady flow process and unsteady flow process, right? So generally we will deal with the steady flow process, and the steady flow process is nothing but with respect to time. With respect to time, um, excuse me. So steady flow process is nothing but with respect to time, the amount of mass of fluid entering into the system is equal to the amount of mass of the fluid leaving from the system must be same, right? So for any given instant of time, the amount of mass entering into a system must be equal to the amount of mass leaving out of the system. Then it will satisfy the steady flow process. A simple example is the amount of steam flowing through a nozzle. Amount of steam flowing through a nozzle is a steady flow process. Nothing but the same mass will be enter into the nozzle and the same amount of mass will exit from the nozzle. Right? And next one is the feed pump. The feed pump supplies water to the boiler at the same rate at which the steam is drawn out from the boiler. Right? So these are the examples of steady flow process. Whereas in case of unsteady flow process, in case of unsteady flow process, with respect to the time, the amount of mass entering into the system is not equal to the amount of mass leaving out from the system. Right? Nothing but the input mass is not equal to the output mass. Right? So that type of process is known as unsteady flow process. It is unsteady flow process. Right? Now, for the steady flow process, we can written as steady flow energy equation. Steady flow energy equation. And examples for steady flow process is a boiler, flow through boiler, a nozzle, turbines, pumps, right, condensers. These are the examples of steady flow process. Now next we will see the second law of thermodynamics. Right? What is the second law of thermodynamics? So again, there are certain limitations arise in the first law of thermodynamics. Limitations of first law applies to the second law of thermodynamics. So without having any backdrop or limitations, there will be no second law of thermodynamics. But there are certain limitations in the first law of thermodynamics. Due to that, there is a rise to the second law of thermodynamics. An important aspect of the second law is its application to heat engine cycle. So important aspect is that heat engine cycle. So what is heat engine? We know that engine is nothing but the device which gives certain output. Hmm, certain output. Now, heat engine cycle. What is heat engine cycle? A heat engine cycle is a series of processes during which there is a net heat flow into the system and net work delivered to the surroundings. There is a net heat flow to the system and net work delivered to the surroundings. The system or device which execute this cycle is called the heat engine. Right? The system or device which execute this cycle is nothing but the heat engine. So heat engine nothing but is a series of processes during which there is a net heat flow to the system and net work delivered to the surroundings. Right? So input we are giving in terms of heat and output we are getting in terms of work during the processes. Right? So the system or device which execute this cycle is called the heat engine. So in continuous cycle, the amount of input in terms of heat will be entered into the system and the amount of output, nothing but work, will be extracted from the system during the continuous cycle. So this cycle is nothing but heat engine. The device which executes this cycle is nothing but the heat engine. Right? So second law of thermodynamics, the performance of the cycle is expressed or is represented by the term thermal efficiency. Is represented by the term thermal efficiency, and generally it is expressed by the equation thermal efficiency. We know that efficiency is equal to output by input. Efficiency is equal to output by input. Now we are dealing here thermal efficiency, nothing but related to heat. What is the output? Output we are getting in terms of work. So output will be in terms of work. So output is nothing but here net work. So without some form of input there is no output. We are supplying some input. What is that input? Heat supplied. So heat supplied is the input and net work is the output. So thermal efficiency is equal to net work by heat supplied. Net work by heat supplied, right? So what is network? Network. So network is nothing but the amount of heat we are supplying and the amount of heat which is rejecting to the surroundings. The difference between these two is network. So heat supplied minus heat rejected is nothing but network to the heat supplied. So heat supplied is Q1 and heat rejected to the surroundings is Q2. So Q1 minus Q2 by Q1 is the thermal efficiency. So in terms of temperatures, it can be written as T1 minus T2 by T1. Right, so this is the thermal efficiency. Next, statement of second law of thermodynamics. Right, so generally there are two statements are there for second law of thermodynamics, and the common statements are one is Kelvin Planck statement and the other one is Clausius statement. Right, so these two persons given two different statements for the second law of thermodynamics. Right, so what is the first statement? First statement which is given by Kelvin Planck statement. It states that, so what he told, it states that it is impossible to construct an engine. It is impossible to construct an engine working on a cyclic process. Right, so generally engines works on a cyclic process. It is impossible to construct that type of engine which is working on a cyclic process whose sole purpose is to convert all the heat supplied it into equivalent amount of work. So what he is saying, it is impossible, it is not at all possible to construct that type of device which is working on a cyclic process whose purpose is to convert all the heat supplied to it into equivalent amount of work. So just now we have said network is nothing but heat supplied minus heat rejected. So as per the statement, it is impossible. What is impossible? Whatever the heat which we are supplying is converted into equivalent amount of work. So that is not possible. So heat cannot be fully converted into work. So that type of device is impossible. So it is impossible to construct an engine working on a cyclic process whose sole purpose, the main purpose is to convert all the heat supplied into equivalent amount of work. That is never achieved. Right? It is never achieved. So in other words, no actual heat engine working on a cyclic process. So in other words, no actual heat engine working on a cyclic process can convert whole of the heat supplied it into mechanical work. It is any kind of device, with the help of any devices, it is not at all possible to convert the total amount of heat supplied into the mechanical work. Right? So that's why it is impossible to construct this type of engines working in a cyclic process whose purpose is to convert the total heat supplied it into equivalent amount of work. So it is not at all possible. So this is a statement given by the Kelvin Planck statement. Right? Now, a heat engine which violates the statement of second law of thermodynamics is known as PMM2. A heat engine which violates this statement of second law of thermodynamics. That is a heat engine which converts whole of the heat energy into mechanical work. Actual practice, it is never achieved, but it is known as PMM, perpetual motion of machine of second kind 2, or 100% efficient machine, which is impossible to obtain in actual practice. Any kind of devices, if it performs the total input into total output, it is known as PMM2, perpetual motion machine of second kind, but in actual practice it is never be achieved. Right? Now we will see with the help of the figures. Figure shows representation of Kelvin Planck statement. What is the figure 1? Figure 1 is shows that source T1, source is nothing but is a reservoir from which the heat is drawn. Right? So source T1, which is at higher temperature, E is nothing but engine. Right? E is nothing but engine. So from the source, the total amount of heat is entering into the engine. From the source, the total amount of heat entering into the engine, right? And now from the E, this total amount of heat is getting converted into equivalent amount of work. Nothing but W is equal to Q1. From the source, the total amount of heat, the amount of heat entered into the engine. From that engine, what it is doing, it is converting into the total amount of heat into the amount of work done. So nothing but W is equal to Q1. Now what it means? It means a device which is violating Kelvin Planck statement. So this type of device which violates a Kelvin Planck statement, nothing but PMM2, right? Now we will see the figure 2. What figure 2? Now again same source T1, nothing but heat which is at a higher temperature entering into the engine. Heat which is at a higher temperature enters into the engine E. Now what is happening? This engine will do some sort of work and it rejects some sort of heat. This engine will do some sort of work and the remaining amount of heat will be rejected to the surroundings. That rejected heat is nothing but Q2. That will be absorbed by the sink, nothing but T2. T2 is which is at lower temperature. Source is which is at higher temperature. Sink T2 which is available at lower temperature. So what does it mean? From the higher temperature, the heat is entering into the engine and some sort of work is done and the remaining amount of heat which is rejecting to the sink. Now that amount of work done is here is equal to amount of heat entering into the engine minus amount of heat leaving or rejected from the engine, Q2. So Q1 minus Q2 is equal to W. So work done is equal to difference between the two heats or two temperatures, Q1 minus Q2. So what does it mean? It means a device that satisfying Kelvin Planck statement, which is known as heat engine. Device that satisfying Kelvin Planck statement, which is known as heat engine. The first figure shows that heat rejected is 0. When heat rejected is 0 means total amount of heat is converting into total amount of work. This type of device in practice never possible. It is never achievable. So the figure 2 will be achievable. Amount of heat enters into the engine and some sort of heat rejected to the surroundings, and the difference between the two entering and rejected is equal to amount of work done, right? So this is about the Kelvin Planck statement. Now we will see the clauses statement. We'll see the clauses statement. What clauses given statement? It states that it is impossible to construct a device. It is impossible to construct a device that operates in a cycle. It is impossible to construct a device that operates in a cycle whose sole effect is the transfer of heat energy from a body at a lower temperature to a body at a higher temperature. So in thermal equilibrium we have studied that heat will be flow from always a higher body to lower body, right? So as per the clauses statement, what he stated that it is impossible to construct a device. What is impossible to construct a device? A device which operates in a cycle. A device which operates in a cycle whose effect is that transfer of heat energy from a body at lower temperature to a body at high temperature. So heat will not flow from a body which is at low temperature to higher temperature. Such type of devices is impossible. Such type of devices is impossible. So another form of clause statement states that heat cannot flow from a body at lower temperature to another body at a higher temperature without the aid of external energy. Without the aid of external energy, right? So what does it mean? That heat cannot flow from a body at lower temperature to another body at a higher temperature. This type of devices is impossible to construct, but it is possible to construct with the help of an external energy, right? So without the aid of external energy, heat will not be transferred from a body which is at low temperature to another body which is at higher temperature, right? So heat cannot flow from a body at lower temperature to another body at a higher temperature without the aid of external energy, right? So this is a statement given by the clauses. Now clauses statements, what he says, the device which is shown in figure 3, it violates the clauses statement because no input work is supplied to the device to transfer heat from a cold body to a hot body. So what figure 3 states? Figure 3 states that lower temperature body which is available at lower temperature and another body which is available at higher temperature, and in between an engine is there, right? So what this figure indicates that it is violating the clause statement because no input work is supplied to the device in order to transfer the heat from a lower temperature to higher temperature. So without the external energy it is impossible to construct. Without the external energy it is impossible to construct. So in this figure there is no external energy. That means it is impossible to construct this type of engine. So this devices violate the clause statement. This figure 3 device which is violating the clause statement. How it is violating? Because there is no input energy. So without input energy it is impossible to transfer the heat which is available at lower temperature to the heat which is available at higher temperature. Now figure 4. What figure 4 indicates? The device in figure 4 does not violate the clause statement. Now figure 3 which is violating the clause statement and figure 4 is not violating the clause statement. How? We'll see. Since work is required to transfer heat from lower temperature body to higher temperature body. Yes. So work is required in order to transfer the lower temperature to higher temperature. The work is required. Right. So this device is called heat pump or refrigerator. This device is called heat pump or refrigerator. In the figure 3 there is no input energy in order to transfer the heat from lower temperature to higher temperature. Whereas in figure 4 there is an input energy in which the heat can be transferred from lower body to higher body. So figure 4 indicates that device that satisfying clause statement which is known as heat pump or refrigerator. Which is known as heat pump or refrigerator. Now clause statement. There is no difference between the cycle of operation of the heat pump and refrigerator. So there is no difference between the cycle of operation of the heat pump and refrigerator and achieve the same overall objective. In order to achieve the same objective, there is no difference between the cycle of operation of the heat pump and refrigerator. But the basic purpose of each is quite different. Of course, the heat pump will have its own purpose, whereas refrigerator having its own purpose, right? So refrigerator which is used to maintain low temperatures and is used for cooling. So generally refrigerator is used for maintaining the low temperature and it is used for cooling purpose. So example for such kind of devices, refrigerator. Now whereas heat pump which is used to maintain higher temperature and is used for heating. So which is used for heating is winter air conditioning. Winter air conditioning is a device which is used to maintain higher temperature and it is used for heating. So this is a clause statement. Now you will see the performance of heat pump or refrigerator is measured in terms of coefficient of performance. The performance of heat pump or refrigerator is measured in terms of COP. So COP is equal to required effect by work supplied. COP is equal to required effect by work supplied. Nothing but Q1 by W. COP is equal to Q1 by W. So COP for heat pump is given as Q1 by W. Q1 by W. What is Q1? Q1 is equal to heat added. So for a heat pump, the output is heat added and input is amount of work. Right? So for COP of refrigerator is equal to Q2 by W. What is Q2? Q2 is equal to amount of heat removed, where W is equal to work input. So in refrigerator, in order to maintain the lower temperature, heat must be removed continuously. So that's why COP of refrigerator is equal to Q2 by W. And efficiency of heat engine is equal to output by input. Output is in terms of work done and input is in terms of heat supplied, right? Whereas in case of heat pump and refrigerator, the output is in terms of heat either added or removed and input is in terms of work, right? The work will be given to the compressor in case of refrigerator, right? Now These are the things which we discussed in this session. Now we'll see a quiz, right? The COP. What is COP? COP is nothing but coefficient of performance. The coefficient of performance is A less than 1 or B greater than 1 and C equal to 1. Less than 1. The COP is the COP coefficient of performance is A option less than 1, B is greater than 1, C equal to 1 and D is any value. So the option is greater than 1. COP of any device should be greater than 1. Now heat pump is used for heating, cooling, both, none of the above. So generally heat pump is used for heating purpose. And PMM1 efficiency. What will be the efficiency of PMM1? PMM1 stands for perpetual motion machine of first kind. A 0, B 100%, C infinity. What is the efficiency? Efficiency of PMM1 is 100%. Efficiency of PMM1 is 100%. So here it's showing infinity, it is 100%. So PMM2 efficiency, A bit 0%, B 100%, C infinity and D is none of the above. So it is 100%. PMM2 efficiency is 100%. So these are the things which we discussed in this session. So what are the things we discussed? In the earlier session we discussed thermal equilibrium, zeroth law and first law of thermodynamics. And in this session we discussed corollaries and limitations of first law of thermodynamics and the second law of thermodynamics. We discussed the second law of thermodynamics. So what are the corollaries of first law? For isolated system, Q and W are 0. So we know that three types of systems are there. Open system, closed system, isolated system. In isolated system, no mass and no energy may transfer takes place into or out of the system. Therefore, Q and W are 0. So as per the first law of thermodynamics, which is applicable to closed system, the equation is Q minus W is equal to internal energy. So as Q is equal to 0, W is equal to 0. So internal energy will be remains constant. U2 minus U1 is equal to 0. Therefore, U2 is equal to U1. The next one, the difference between heat supplied and work done during a non-flow process results in change in the property of the closed system, and it is referred as internal energy. Yes. Now, in a thermodynamic cycle, in a cyclic process, the net heat transfer is equal to net work done. If a system does not follow a cyclic process, what will happen? The energy input will not be equal to the energy output. Therefore, a property may occur. It is known as internal energy. Nothing but Q minus W is equal to U. Right? A PMM of first kind is impossible, obviously. A device that will deliver work continuously without some form of input is called PMM1. So without any input, there is no extraction of output. Such a device is impossible to construct. That device is PMM1. Limitations. Limitations says that it does not specify the direction of flow of heat and work. In which direction does the heat will be transferred and in which direction does the work will be done, it does not specify. In actual practice, the work and the heat cannot be fully converted into work. So heat and work are not fully mutually convertible. It does not help to predict whether a system will or will not undergo a change. So as per the first law of thermodynamics, it is saying that a system will undergo a cyclic process, heat and work are mutually convertible, but it does not predict whether it will undergo the process or it will not undergo a process or change. Right? So second law of thermodynamics given by two statements. One is Kelvin-Planck statement, the other one is Clausius statement. Now heat engine cycle is nothing but heat engine cycle is a series of process during which there is a net heat flow into the system and net work delivered to the surroundings. So net work flow into the system in a cyclic process. The heat flows into the system and the work will be delivered to the surroundings. Such a type of device is known as heat engine. The thermal efficiency is nothing but amount of work done by heat supplied, right? So what is the statement of second law of thermodynamics given by two persons? One is Kelvin Planck and the other one is Clausius statement. So it states that it is impossible to construct an engine working on a cyclic process. So this type of device is not at all possible to construct on a cyclic process whose purpose is to convert all the heat supplied into equivalent amount of work. All the heat supplied into equivalent amount of work, it is not at all possible, right? So no actual heat engine working on this process can convert whole of the heat supplied to heat, right? So Kelvin Planck statement, the heat engine which violates this statement, that is second law of thermodynamics, is known as PMM of second kind, that is 100% efficient machine, which is impossible to obtain in actual practice. So these are the two figures shown by Kelvin Planck statement. First figure is that only input energy is supplied and the same input energy is converted into equivalent amount of work, and there is no rejected of heat from the system. So this device violates the Kelvin Planck statement, that is PMM2. So heat rejected is zero, therefore this device is impossible to construct. Whereas in figure 2 it shows that the heat is entering into the system or engine and it will do some sort of work and the remaining portion of heat will be rejected to the sink. So the amount of work done in this case is equal to difference between the two heats, nothing but Q1 minus Q2. So this type of device which satisfies the Kelvin Planck statement is known as heat engine, right? The next one is Clausius statement. So it is impossible to construct a device that operates in a cycle whose effect is the transfer of heat energy from a body at lower temperature to a body at higher temperature. So in thermal equilibrium, we studied that heat can be flow from higher body to lower body, right? So after certain time, the heat cannot flow between these two bodies because it will attain a thermal equilibrium, right? So in Clausius statement, it says that heat the device, it is impossible to construct which operates in a cycle whose effect is that transfer of heat energy from a body at lower temperature to a body at higher temperature. So this type of device is impossible to construct, right? So another form of statement we can the clause is given that heat cannot flow from a body at lower temperature to another body at higher temperature without the aid of external energy. So with the help of external energy, heat can be flow from lower to higher, right? Now, this figure shows that first figure is that heat is flowing from lower body to engine, and the engine from the engine, and again the same heat is flowing to the higher temperature. That means without some form of input energy, heat cannot be flow from lower body to higher body, right? In the figure 4 it shows that there is an input energy is there. So with the help of this input energy, heat can be flow from a lower body to higher body. So this type of device satisfies the Kelvin Clausius statement, right? So Clausius statement, there is no difference between the cycle of operation of the heat pump and refrigerator and achieve the same overall objective, but the basic purpose of the heat pump and basic purpose of the heat pump and refrigerator is different. A refrigerator is a device which is used to maintain the low temperature and is used for cooling purpose. So such a device is known as refrigerator, whereas heat pump is a device which is used to maintain high temperature and it is used for heating, which is known as winter air conditioning. So COP is given. COP is nothing but efficiency is output by input, air input by output, nothing but input is the required effect, nothing but heat supplied and required effect, COP is equal to required effect by work supplied. COP in case of heat pump is Q1, nothing but heat added by W, nothing but work. So COP of refrigerator is Q2 by W, nothing but heat removed, and W work done. So thermal efficiency of heat engine is given by output by input. Output will be always in terms of work done, and input will be heat supplied. So these are the things which we discussed in this session, and in the next session we will see some more corollaries of second law of thermodynamics, and we'll solve some problems. So I hope this session is this session you have understood. Thank you, and we will meet in the next session.